Okay, we're back again. We're going to look at FRQ number 3. If you looked at my first two from this year, you know that I'm doing this not as I'm doing this with the intent to make sure students know that we can all make mistakes and that we don't have to be perfect to do well. I haven't looked at the FRQ number 3, but here we go with number 3. I'm going to put the link to the released FRQs on the College Board site in the description down here in the video. So please open that and follow along as we solve it so that we don't have to put the College Board's copyrighted material on the on YouTube. So here we go. Number 3, Miss Fay is a manager's restaurant. To improve the dining experience for customers, she uses a digital music service to create a playlist of songs that we played in the restaurant. The playlist contains 1,000 songs, consists of 4 different types of music in the following quantiles. 200 songs country, 400 pop songs, 100 rock songs, and 300 jazz songs. The digital music service will select songs at random from the playlist to be played in a restaurant. Any song can be replayed at any time. Part A. Part A consists of 2 parts. So part A1. Suppose one song is selected at random. What is the probability that the song is a rock song? Show your work. So if we select one song at random, there's 1,000 songs. And we have, let's go ahead and set up a random variable here. Let's let X equal the song. We can't do random variable. Let's do it like this. This is not the probability. Probability of one that's a rock song. Probability of one song that's a rock song is going to be the number of rock songs 100 over the total number of songs. So equals 0.1. Part 2, suppose 2 songs are selected at random to be played. What's the probability that both songs are rock songs? Show your work. Select songs at random from the playlist to be played in a restaurant. Any song can be replayed at any time. So that means that they could play the same song twice in a row. So in this case, we want probability of rock song and rock song. 2 songs in a row. The fact that these songs can be replayed at any time means the probability is going to remain the same all the time in the 1,000 songs. That song has the same probability. So that means this is going to be the probability of a rock song times the probability that the second is a rock, given that the first one was a rock, because it's the first rock. Since they don't change, that's the probability of rock times rock. Probability of rock song, that's probability of rock song, or 0.1 times 0.1, or 0.01. 2 songs selected randomly played, which is probably at both the rock songs. That's the work showed. That's part 2. All right, B. In every 1 hour period, 20 songs will be played at random, and any song can be replayed at any time. Ms. Fay is interested in how many rock songs will be played in a typical 1 hour period. Define the random variable of interest to Ms. Fay and state how the random variable is distributed. All right, so B. Now we define the random. So let's let X equal number of rock songs played in 1 hour. And since it can be played anytime, probability of choosing a rock song on any number is going to be the same. So that means this is going to be X is a binomial distribution. With N equals 20 and P equals 1/10. or 0.1. What is the expected value for the random variable in part B? Show your work. That means we're looking for the mean of x. That's the expected value of x. And that's n times p, or 20 times 1/10, which is 2. So that means that on average, over many hours in the restaurant, we would expect an average of 2 rock songs per hour to be played. Make sure y'all can still see my work there. Yeah, good. That was part 2. Let's do C1. Recall in every 1 hour period, 20 songs will be played at random. Each song will be replayed at any time. Determine the probability that 4 or more rock songs in a particular hour will be played. So that means X is our probability distribution. And the probability that X equals X. And this could be 0 rock songs, 1, 2, 3, all the way to 20 rock songs in 1 hour. We want 4 or more rock songs. Let me go and put 4 here. And so this is the probability that I'm looking for. So I can say here that the probability that X is greater than or equal to 4 is equal to the probability, 1 minus the probability that X is less than or equal to 3. And I can do that because my calculator does binom CDF, counting up to 3. So 1 minus binom CDF, where I have, I'm going to go ahead, it's going to take me a little extra time here because I did not pull up the calculator on the computer. So I'm going to do that real quick. I did not think about this while I was doing it. I haven't used the calculator yet, have we? So I'm going to type in binom CDF. Let's see here. So I do second. Oops. Sorry for the delay. Should have had this pulled up already. So we're going to go second vars, distribution. I'm going to go to binom CDF. And it wants the number of trials. Some people don't like it. Using the calculator syntax. Let me double check, make sure you can still see that. You can. All right. And the probability is 1/10 again. And our X value this time is 3. So now I'm going to do 1 minus all of that in the calculator. So type this in the calculator. 20 trials, 0.1 for the P, and the X value is 3. Paste. And I'm going to do 1 minus that. And that's going to give me, let me double check that real quick. 13.3%. Or I'm gonna go ahead and put 1 minus binom CDF. Let's just do 1 minus probability. X is less than or equal 3 is equal to 0.13295. Close enough. Let's go back to the question now. Where did my question go? There we go. We've got everything defined, distributed. We should be good with that answer. Part 2. Suppose 4 rock songs are played during a particular 1-hour period. Does this provide strong evidence that the song selection process was not truly random? So let's calculate the probability that X equals 4. Do this with binom PDF. Files 20, P 1/10. Oops. X equals 4. And let's calculate that really quick. Maybe not really quick. Second bars. Binom PDF. Twenty 0.1 4 paste. So that's the probability is 0.08977. Okay, so what we're going to say is, let's go back and look at the question again real quick. Question was, does this provide strong evidence that the song selection process was not truly random? Justify your answer without performing an inference procedure. All right, so I'm going to say no, it does not provide strong evidence because there is there's approximately 9% chance in any particular hour that 4 rock songs will be played. So almost 1 in every 10 hours we would expect 4 rock songs to be played. Therefore, 4 rock songs played in an hour, particular hour, do not provide. Let me make sure y'all see it. Yeah, you can't see that very well. Do not provide strong evidence. selection process is not random. Maybe a little wordy, more wordy than necessary. Probably more wordy than you'll see on the model solution. Okay, but that does for number three, the probability, the probability problem for this year.